Morning, guys. Today we're going to take a look at pages 8 and 9 of the Unit 6 Classwork packet. The topic for today is something called the Incenter. Now, in order to understand the Incenter, I want you to first recall what we said about the circumcenter. We said that the circumcenter was the center of a circle that was drawn around a triangle, right? By contrast, when we talk about the incenter, instead of drawing a circle around a triangle, we're actually going to be drawing a circle inside. And thus, the incenter is just the center of a circle that's drawn inside. Hence the term incenter. Okay? Now, there is an important difference between the incenter and the circumcenter. The incenter is formed by the angle bisectors. The angle bisectors, write that down, of the angles of a triangle intersect at a point called the incenter. The incenter is equidistant from the sides of a triangle. The incenter is always equidistant from the sides of the triangle. Okay, so let's actually look at this in that diagram you guys have drawn on the left-hand side, okay? So the angle bisectors, those are going to be the things that come out of the angles. They divide the angles into two equal parts. So my angle bisectors would be AP, CP, and BP, like the gas station, all right? The incenter would just be where they cross, right, which is point P. And when we talk about the congruent segments, think about the special property that we know this time. They told us that the incenter is equidistant from the sides. In other words, if you put your finger on the incenter and you go to a side, it's going to be the same for all three. So in this case, DP, EP, and FP will all be congruent, okay? With that being said, let's take a look together at two examples of how this would work in practice, starting with example number 1. All right, so first things first, let me draw this triangle we've got here. So JNKOL, JNKOL, and what's that one other one? That's M. All right, and then, all right, so my angle bisectors all meet at point P, which I'll call right here. All right, and then they tell me a few pieces of information, right? All right, so that's 8, 13, 17, and they tell me these are all right angles because that's what it means to go straight across, right? All right. Okay, guys, so with that being said, let's take a look at what we actually know about this particular triangle, okay? Because the incenter is formed by the angle bisectors, what we automatically know is that these two itty-bitty angles are the same, these two itty-bitty angles are the same, and these are the same. Now, we don't necessarily need to write all this information in, but this is a personal preference. I always like to, just in case, all right? Similarly, the special property of the incenter is that it's the same distance away from each one of the sides. Well, that means that starting here and going to a side, it's the same everywhere. So these are also 8. All right, with that information, let's see what we can actually find out. Do I know NP? NP, yes I do, it's 8. Hooray, 1 point out of 4, awesome. Do I know NK? Let's take a look. Do I know NK? Not yet. However, I want you to notice something about congruent triangles, right? Notice that by A or AAS, these two triangles are congruent to each other. So if this is 17, this is also 17. I know that's a little bit hard to see, but it actually relates to what we did before about angle bisectors, if you go back to your angle bisector theorem page, all right? All right, PK, where's PK? PK. Now this one, I may actually have to use my best friend, the Pythagorean theorem. Notice I have two legs and I want to find the hypotenuse. So to find PK, I would do 8 squared plus 17 squared equals c squared. 64 plus, sorry about that, 289 equals c squared. Let me actually add those numbers together. Hold on. 9, 5, 1. All right, so 353 equals c squared, and rad 353 equals c. All right, so I'm gonna be honest with you. I have no idea if that can actually be simplified. Okay, so I'm just gonna assume we're gonna leave it right now because we have more important things to do. So this right here is rad 353, and last but not least, they ask us about LO. Once again, this is gonna be a Pythagorean theorem problem. I have a right triangle right here, I have a leg, and I have a hypotenuse. So this one, instead of plugging in for A and B, I'm going to plug in for A and C. So that means I'm going to do 8 squared plus B squared equals 13 squared. 64 plus B squared equals 169. Subtract 64 from both sides, and I get B squared equals 105. And that means B equals rad 105. Okay, so one thing I want you guys to see from this is that the Pythagorean theorem will appear quite often inside both circumcenter and incenter problems. So if you're not comfortable with the Pythagorean theorem and how to apply it, yeah, we need to have a little talk, okay? The second example we're going to take a look at is actually on the following page, page 9, and we're going to take a look together at example number 3. Okay, we're going to take a look together at example number 3, which is a problem that involves angles instead of sides. Let's take a look, okay? All right, so example number 3, they give me this like long, skinny triangle, okay? And let me draw some stuff in here. All right, angle bisector, angle bisector, angle bisector. And that's PSQR. Cool. Okay, so what I actually do want to do, guys, is I want to put that information they gave me in the problem in the diagram itself. Okay, so angle PRQ. PRQ. So the whole thing is actually 8x minus 10, okay? So the whole thing is 8x minus 10. Angle RPQ, so that angle over here, which I'll do in purple, is 4x minus 14. 4x minus 14. And then they give me angle PQR, which is this corner over here, and that's 7x minus 5. All right, 7x minus 5, cool. Oh my god, how the heck am I supposed to find any of these other angles, guys? Here's the thing. This is where I get lucky because I can go back and use stuff from previous units. What do you guys know about how many degrees are inside a triangle? 180. So in order to first find what x is, all I gotta do is plug in. Well, I'm so sorry, what did I say plug in? All I have to do is set up an equation, combine like terms, and set an equal to 180. I need my head examined, I'm so sorry. Okay, so what's my equation gonna be? 4x minus 14 plus 8x minus 10 plus 7x minus 5 equals 180. By combining like terms, 4x, 8x, that makes 12x, plus 7x gives me 19x. I lost 14, and I lost 10 more. I lost 24, and then I lost 5 more, so I lost 29 equals 180. Add 29 to both sides, then I get 19x equals 209. Divide both sides by 19. All right, so let me do that division. Goes in once, minus 19, 11. Cool. Okay, so once ooh, no, did I just... No, you guys can kind of see it, right? Okay, good. Anyway, so I just found that x is 11. How do you think I would find each one of those angles in the corners? All I have to do is substitute back in. So I'm going to take that 11 and I'm going to plug in over here. That's going to give me 44 minus 14, which is 30. Over here, 88 minus 10 is going to give me 78. And over here, 77 minus 5 is going to give me 72. And if I actually do go and check to add those all up, I'll be good. All right, so far so good, right? So let's see what we can start doing. Do we know the measure of angle PRQ? This one right here? Yes, we do. It's 78 degrees. Do we know RPQ? This one up here, the whole thing. Yes, we do. It's 30 degrees. Do we know PQR? This one in the corner. Yes, we do. It happens to be, what did I say it was? 72. Now let's start filling in the harder bits, all right? Now they're gonna start asking us for other angles. For example, RPS, RPS. So this itty bitty one right here. Well, look guys, because it's an angle bisector, what does an angle bisector do to an angle? An angle bisector splits an angle into two equal parts. So if this whole thing is 30, what's this piece? It's gonna be 15. Okay? Similarly, what if they ask you for PQS? Well, I know PQS, so they want this itty bitty one right here, right? So the whole thing is 72, so that means that this small piece is 36. And then they ask me for PRS over here. Whole thing is 78, and half of 78 would be 39. Okay, now for the challenge question. They asked me for the measure of angle PSR. Now they want to know this one. Well, guess what, guys? If I've used up 15 degrees and I've used up 39 degrees in a triangle, how many degrees are there in total? Well, there are 180, so all I got to do is add up 15 and 39, which gives me 54, and then just do 180 minus 54, and I get 126 degrees. Ay, ay, ay. Okay, so again, guys, angle bisectors form the incenter. The incenter is the intersection point of the angle bisectors. The special property of the incenter is that it's the same distance away from the sides, okay? Within incenter problems, you may have to use the Pythagorean theorem, as we saw in example 1, or you may be asked to use the triangle sum theorem and properties of angle bisectors, as we saw in example number 3.